Hello everybody and welcome back. We're looking at question 24 in this video from our 2018 Pascal contest. In Mrs. Warner's class, there are 30 students. Strangely, 15 of them have a height of 1.6 meters and 15 of the students have a height of 1.22 meters. Mrs. Warner lines up n students. I'm going to guess we have to figure out what n is, so that the average height of any 4 consecutive students is greater than 150 meters, and the average height of any 7 consecutive students is less than 150 meters. Or, sorry, not 150, 1.50 meters. What is the largest possible value of n? Okay, so I see, I don't know why they didn't just list these in order, but 8, 9, 10, 11, 12. Okay, so we might try and do sort of what we might call sort of a constructionist approach, and we could either start at the end and say, well, there's got to be some way to make 8, because 8's the bare minimum answer. Or we could say, well, let's just jump for the biggest. Could we do 12? And if we can't, why not? And maybe that falls back on 11 or 10 or something like that. So you can either start with the biggest number or the smallest number if you want to just start diving in and constructing things. I'm going to instead take a look and say, well, if I've got 4 consecutive numbers and 4 consecutive students, and the average is greater than 1.5, well, how many of the 1.6 students could I have, and how many of the 1.22 students? I need to have at least some 1.60 students, because they need to sort of balance out the shorter students, the ones who are below 1.5. And that's what I'm going to take a look at first. So, for 4 students, the average needs to be greater than 1.50. Can we have 1, 2, 3, or 4 1.60 students? So we can definitely have 4, because that would make the average just 1.60. Now if I have 3 of them, that's 3 students who have a height of 1.60 and 1 student that has a height of 1.22. So if I wanted to figure out their average, 3 times that plus a 1.22 student, divide that by 4, so you get 6.02, divide that by 4, and that's 1.505, and I'm inclined to believe that you can't do it with 2. But let's just check. 1.60, 1.22, and no, that's an average of 1.41, so obviously you can't do it for 1 either. So if I'm going to have 4 students in a row, I need to have 4 of them be the tallest type of students, or 3 of them be the tallest type of student. Okay? You can't do it with 2, you can't do it with 1. So that's an interesting constraint. We might even start labeling our students with something like, we say H is the 1.60 student, and little h is the 1.22 student. So I could never see something like H, 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 because that average is too small. I'd need to have another capital H somewhere in there. So basically what we're asking for is, what's the longest string of capital H's and little h's that we can make? And that's going to be the n value. Okay, now for 7 students, how many 1.6's can I have? Because the average needs to be less than 1.50. So could I have 7 of them? No. 6, 5, I don't think so. For 7, the average will be 1.60, so that's out. For 6, and for all of these, if we say k is the number of students, it's going to be k times 1.6 plus 7 minus k times 1.22. Divide that by 7. So just so I don't have to keep repeating the calculation, I can just grab my calculator right now and do it. So the average for 6 of them is 1.54. The average for 5 of them is going to be 1.49. So 5 or lower is what we need. Okay. So let's imagine I had 7 students in a row. So I've got 4 groups, or 2 groups of 4 right here. Now I need to have at least 3 students with the H height, the capital H height, but I need to have at most 5 students with that capital H height. So could I have something like H, 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 little h, 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 H? And the answer is no. I'd have 6 capital H's here, so we've got a little bit of a problem. So we could change things up and have a capital H in the middle, and then 2 capital H's over here and 2 of them over here, and that would be my maximum of 5. Now, can I do better than that? Well, no, I need to have 2 H's over here and 2 H's over here, and so this is true for any group of 7, right? Any group of 7, but as soon as I do that, everything else is happy. So, for example, we could have H, H, little h, H, little h, H, and this should work. Well, hold on. That's another group of 4, and that's fine. But then, so that would be 2 capital H's and 2 little h's, so that doesn't work. So my little h's have to be placed more than 2 apart. Nifty. So what else might this tell me? So I have to have a capital H there. Now, could I have a little h here? Well, if I did, I'd have to have a little h here. And the in-between it would all be capital H's. I could also have a little h here, and then the other little h's could be here or here. And if I put it here, then they could be in all of those spots. But we need to make sure that as we try and create some sequences, my little h's are always at least 3 away. So I think we're ready to try and experimentally make some things. So 4, 5, 8, 9, 10, 11, 12. Okay. So I want my little h's to be as far away as possible. I also know that anytime I have a group of 7, so 1, 2, 3, 4, 5, 6, 7, so anytime I have a group like that, I have a capital H right in the middle. Right? So anytime I have a group of 7, I have to have a capital H right in the middle. So what if we were to go all the way to the end with 12? So if I had 12 of them, then I'd have to have an H here for the middle of these 7. I'd have to have an H there for the middle of those 7, an H there, and an H there. I'd need to have 6 H's here, right? But that is going to throw off, say, this group right here, because that's 7 of them, but that has 6 H's, so we've got a bit of a problem. So I can't do 12. Could I do 11? I think I could. I'll just have a group of 5 H's right in the middle. So I could have H, 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 and that's allowed because then the middle group of 7 will just put the 2 little h's there. And then no, I don't think this will work either because we can't have little h's here. because then that group of 4 is unhappy. So that's got to be a capital H. Same as both of these have to be capital H's. But then we're running into another problem, whereas so this group of 7 has 1, 2, 3, 4, 5, 6 H's, and that's not allowed. So we've got a little bit of a problem there. So you can't do 11 because you'd need to have an H in the middle of this group of 7 and an H in the middle of this last group of 7 and H's in the middle of all the groups of 7 in between. So we can't do 11 either. Let's try 10. 6, 7, 8, 9, 10. Again, from the third point on, you're going to have H's up until the last 3 might not all be capital H's, just because you have to satisfy these groups of 7. Okay, so if that's the case, then what could we have? Well, we could have... Again, we're going to have a group of 7 here that has a little bit of a problem. Because I'll need to have 2 little h's, but they can't be the required at least 3 spaces apart. So I can't do 10 either. So we're down to 9. Again, middle h's. Now I've got 3 h's in the middle. This is going to be a little better because now this group of 7 I could get a little h here and a little h here. Right? And then, so that would be fine. And then what about this group of 7? It's got its 2 little h's. And this group of 7 also has its 2 little h's. And we just check, are all the groups of 4 satisfied? Yes, 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 and yes. So 9 is the bare minimum that we can do. You can't do 7... you can't do 11 or 12 or 10 because that middle group of capital H's just sort of spoils it. And it spoils at least one group of 7. So our answer is going to be 9, and 9 is D. So that's what we'll bubble in, D. And then let's get ourselves a fresh sheet of paper because we are on the last question now. It'll be question number 25. We'll be taking a look at that in the next video. So until then, take care and, keep enjoying math.